Hello everyone, and thanks for watching my videos. In this video, we're going to be going over how to assign the molecular geometry of covalent systems or covalent molecules. As I described in my previous video about laws of structure and how to draw laws of structure of covalent molecules. The next step after you draw laws of structure or laws electronic of structure is to assign the molecular geometry and understand how the arrangement of these electrons that we described in laws of structure are basically going to be represented in a given molecule as a 3D structure. Because remember, at the end, the chemical reaction is happening in 3D. Everything is happening in 3D in our life. So at the end, you need to understand where the bonds is going to be aligned in which, again, directions, where the lone pairs is going to be aligned in what directions. So, because at the end, the chemical reaction is going to happen by these electrons, as I mentioned before. It's a bond breaking, bond forming. You break bonds, you form bonds. And the electronic arrangement is going to matter in the chemical reactions. And it's also going to matter in the geometry of the molecules and how this will affect the polarity. When you say a molecule is polar versus molecule is non-polar, that is going to be affected by the molecular geometry and the interaction between the atoms, the electronegativity difference between the atoms. So without further ado, I hope you enjoyed the video. So this video is targeting the molecular geometry of covalent molecules and how can you assign successfully the molecular geometry of a given molecules using lowest electronic dot structure. Thank you.
These are the different cloud geometry that a covalent molecule can take. A covalent molecule can be a linear. A covalent molecule can be trigonal planar. A covalent molecule can be tetrahedral. A covalent molecule can be trigonal bipyramidal or octahedral. Who's going to tell us what? Who's going to tell us how they're going to exist? Laws of structure. Laws of structure is going to tell us if they're going to be in linear, it's going to be trigonal planar, it's going to be tetrahedral by the charge cloud. Draw in chapter 7. These are charge cloud. This is an electronic cloud. This is an electronic cloud. So how this electronic cloud can exist, how this molecule can exist. You have two charge clouds, as you can see here, the double bond, triple bond, single bond, they all count as a one charge cloud. So this is one charge electronic cloud. This is one charge electronic cloud. How this can exist? Can carbon be a 90-degree? Can carbon be a 90-degree molecule? Can carbon be a bent molecule? Carbon dioxide, I mean. Carbon dioxide will exist as linear. Why it will exist as linear? Because this is the optimum separation between the bonding clouds, so they don't repel each other. If you put carbon dioxide in a bent structure, or you put carbon dioxide in a 90-degree angle, this is more repulsion than when they're 180. So the whole idea about the covalent molecule exists is about minimizing the repulsion, is by minimizing the repulsion between the different electronic clouds. What are the different electronic clouds that we have? We have bonding clouds, as you can see here, and we have non-bonding clouds, as you can see here. So water will have non-bonding cloud repelling each other. Carbon tetrachloride doesn't have any non-bonding cloud, but has a bonding cloud. But how many charge clouds are in here in carbon tetrachloride? 4 charge clouds. If you have 4 charge clouds, what would be the molecular geometry of carbon tetrachloride? You will look at here. Here is the cloud geometry of 4, tetrahedral. So carbon tetrachloride will be a tetrahedral cloud geometry. And the same thing, carbon dioxide will be linear. This will be tetrahedral. Why this is tetrahedral cloud geometry? I'm talking about cloud geometry, not molecular geometry. This will be 4 charge cloud. Each lone pair count as 1 charge cloud. So 1 charge cloud, 1 charge cloud, 1 charge cloud, 1 charge cloud. And that will result in 4 charge cloud. So water is going to have this cloud geometry, 4 charge cloud. So this is a cloud geometry based on the number of bonding cloud, non-bonding cloud. And as you can see, I went back to chapter 7. And every molecule would row, we can identify the cloud geometry. Every molecule would row, we can identify the cloud geometry. What is the cloud geometry for this molecule? How many charged clouds surrounding the sulfur? 1, 2, 3, 4, 5, 6. Going back to the table, what is the geometry of 6 charged cloud? Octahedral. This will be octahedral. So this molecule here will be in an octahedral arrangement. Draw laws of structure. If you have a specific molecule, you know already the arrangement in that specific molecule. When I mean arrangement, mean the bonding arrangement, the non-bonding arrangement. We draw multiple examples in chapter 7. We draw multiple laws of structure. We use the 5 steps, the fundamentals of laws of structure. Once you reach the final laws of structure out of these 5 steps, what's your next step? Your next step is to identify the cloud geometry surrounding the central atom. So right now there is no atom but one. All what you see is one atom because we haven't connected the molecule yet. Once you start connecting the atoms, as you can see, in this case, this is from laws of structure. What you got is 3 bonding cloud. So you draw laws of structure, you end up with this arrangement. What will be the cloud geometry? How this can exist in space? How can this exist in 3D? So the electron geometry for a 3-charge cloud is going to be trigonal planar. The bond angle is going to be 120, which is separate the cloud from each other. The molecular geometry is the cloud geometry. So why is the molecular geometry agrees with the electron geometry? Because you don't have any non-bonding cloud. Once you start having non-bonding cloud, your molecular geometry is distorted, as you can see right now. So you still have 3 charged cloud, but one of these charged cloud is lone pair. So what will be your molecular geometry? You will be looking into the bonding cloud, and you can see it's a bent structure. So this is the thing that you need to notice. Again, once you have a lone pair, you have a distortion to the molecular geometry. Charged cloud, and you can see it's a tetrahedral with a bond angle 109.5. And again, if you add 1 lone pair instead of bonding cloud, you're gonna distort the structure, as you can see. We also looked into the 5 charge cloud geometry, as you can see. You remove 1 more and add a lone pair, you're distorting the geometry even further. If you remove 1 more and add lone pair, you can see this is the maximum number of lone pair you can add here. And your geometry is totally different, as you can see, it's a linear. So again, who's telling us all of this? Laws of structure. The fundamental of these, again, covalent molecules and molecular geometry of covalent molecules is understanding laws of structure. And as I said, laws of structure is the beginning of Chem 102. Understanding how to draw the covalent molecules, you'll be able to understand how they interact with each other. Then went over the final structure, which is 6 charge cloud, which is octahedral. And you can see, again, we can remove 1 and we'll put non-bonding cloud and it goes in the axial, and that will be distorting the structure, as you can see. Remove 1 and add lone pair, and you end up with square planar as a geometry. So I hope this is clear to everybody. I hope this, again, following this simulation was helpful.
Thanks for watching my videos.